I've been in this now for about almost 34 years.
Wow,
And
awesome.
yeah, and some of the guys, especially in Canada, will remember the ECI and EIL controls. There's still some of that out there, but that's where I got my start. I was there 10 years, and then we were acquired by Danfoss, and that was 25 years ago, basically. So I spent a lot of time in tech support and going out into the field as well, because you know how valuable that is.
Yeah.
And yeah, so a lot of field time, and then a lot of tech support time.
Yeah.
Uh, Learning how to ask the right questions, how to sense the frustration in someone's voice, and figuring out how to help them, and then trying to frequently turn a negative into a positive by doing a little training with them
Yeah.
while we're on the phone.
Yeah, and that is tough. And I think that's one of the biggest things about a refrigeration technician or professional's job, because asking the right questions is, I think, is really key, especially for refrigeration, because there's so many different dynamics versus like if
Right.
you're talking about an RTU, or if you're talking about an air handler, there's only so many things. But when you have a controller and a full control system, there's more to be asked than being answered right away. Because I'm sure a lot of people would call up, and you've probably seen this over the years. They'd call up and looking for an answer right away on a
Yeah.
question that there's many more questions that need to be answered first.
Right. Right. Yep. Yeah. So yeah, I have to ask lots of questions um, to find out really going on, and it's a matter of asking the right questions and kind of asking leading questions to get those little details that help me piece together what's really going on. And I've been kind of lucky, really, because in all those years in tech support, Danfoss and even ECI has allowed me to kind of see it through, not just get the call, give an answer, get off the phone, get to the
Yeah.
next one. They let me see it through to the point where I can say, hey, did that really work? Did that fix that problem? Because then I'll remember that for next time.
Yeah. What are this is a good thing. What are some things that over the years, because you've done so much technical support, what are some questions technicians, if they asked a little differently or maybe in a different way, that would really help you as a support expert in the field? If they call anyone, even they're calling their lead technician, you, because this is what a lot of it is. A lot of apprentices, and they get hired on and they start
Hmm.
for a company, and then they rely on that lead technician. And then the lead
Yeah.
technician kind of gets frustrated, right? Like, oh,
Yeah. Yeah.
you've been in the refrigeration industry for 4 years, and you know what I mean. You're asking me these questions. What are some of
Yeah.
those questions that, if say a newer technician or even a more experienced technician asked, would really
Hmm.
help that conversation go quicker or better?
Well, yeah, I think I do appreciate when they tell me up front that I don't know.
Yeah,
I don't know this, or I don't know that, or I'm not familiar with this control. Even if they say I don't like your control, I'm okay with that, because then I know where we're at, and then I know basically where to start them with. Obviously, we don't start by saying, "Okay, let's check the fuse," that kind of stuff. But I know kind of how deep in to start with them, because if the guy says, "Hey, I'm pretty familiar with this stuff. I can do calculations," then I know, okay, we're going to the advanced level right away, and then I can start kind of probing around and see what have they tried so far, and also um, like, is there anything for me to teach this guy while we're at it? Because you'd be surprised how guys work with this every day, but there's those little details that can be missed. Like, for instance, a guy said, "Hey, this controller, just the fan relay, or the fan delay is not working on your case controller." Um, 2 or 3 conversations later, we realized that he didn't really know how it worked,
mm,
and he didn't really know, because no one showed him that, hey, it's a time and a temperature thing,
mm.
and he thought that it was one or the other, and that if you set the delay to 0, that meant it ignored the delay. So yeah, it's those little things that you find out that you can't assume that they know all the answers just because they've been around it for a while.
Yeah. And that's, I think that's the key too, is like I've been training so many people, like just like you've trained thousands of people just like me. And over the last couple of years, just diving into people, okay, I've been doing this for 10 years, doing supermarket refrigeration. But when you dive a little bit deeper, it's like that's how they were taught and it worked. But
Yeah.
there's always that
Yep.
fine detail. They're like, oh, smokes, Trevor.
Yeah.
I was fixing this all these times, but I didn't know that's why it was fixing the problem. That the
Right.
the underlying thing, which you're
Yeah.
kind of talking about there,
Mhm.
which is so cool.
Yeah.
Yeah. So then a couple of years ago, Danfoss said, hey, let's take some people and put them, let's assign them to accounts as an application engineer. So that's how I got involved with some of the bigger accounts like Ahold and Albertsons and Wise Markets and ShopRite
Yeah.
here in the States. And so that was I wasn't sure it was a good thing at the time, but it was a good thing because I ended up going to the West Coast 4 times last year to help with CO2 startups. And so that was an opportunity for me to learn and for me to teach at the same time and kind of see the whole puzzle come together, both on the case side and the rack side.
Yeah.
And it's been a good experience, and it gives us a chance to say, okay, this is how Danfoss does CO2. This is how it all comes together. And then when the rack's not running, here's where we start.
Yeah. And I like that, because this is what I talk about in all our CO2 trainings, like diving in deep, is to get that understanding of what are you working with? What is the overall picture? What are you trying to solve? And like what you said earlier is that sequence of operation of that controller, time and temperature.
Mhm.
Do you understand the sequence of it? And I think that's
Yeah.
a lot about CO2, because you're a Danfoss expert, control expert, but you go into CO2 now, there's some differences. So
Mhm.
you're learning along the way. And
That's
this
right.
is what I talk about technicians in my training program. If you're there with the expert, like from Danfoss, they're still learning too. They're the expert,
Yep.
but things are
Yep.
changing at such a rapid pace that we're all learning. And it doesn't matter
Right.
if you're an expert in any big manufacturers. We're all learning as we change and evolve with CO2. And this is what we're going to
Yep.
dive into today. So you started in CO2 years ago, learning about it and controls, but really diving in now over the last couple of years in transcritical CO2.
Right.
So how's that experience been so far? So let's start with working with the contractors on this.
Yeah. So some of it, of course, started just over the phone and trying to figure out what's going on here. Why isn't this working? And why is my receiver pressure so high and stuff like that? But it really didn't come together until I got out in the field and we got together with the contractors and the EMS guy and the OEMs from the rack manufacturer to say, okay, we think we're going to have this thing running in 3 days. So where do we start, kind of thing. So it's been good because yeah, we can get some training in and we can explain, and it's answering, as you know, it's answering a lot of questions.
Yeah.
Like, hey, why isn't this case running? Why is our superheat low? Why is all this happening? And I can say, okay, here's where we're going to look. And fortunately, the controller allows us to customize screens for them. So when they log in, they get an overview of everything, the critical pressures and temperatures and valve opening degrees and stuff like that, so that if they're completely lost, they can log in, they can see all that on one screen, and then I can start asking questions if they come to me and say, what's going on with this thing? So that's been good. But yeah, it's answering a lot of questions and running through startup sequences and stuff like that to say, this is what you should expect. And if this isn't working, here's what you can test with your meter to see what's going on with it.
Yeah. And I totally agree with that, because I consistently talk about that when I'm working with a contractor or a technician. I'm like, you want to work with the manufacturer and get a better understanding. Because yes, maybe there was a parameter that is not the right one that the OEM of the equipment put it in, or was recommended, but was never looked at going down the road when they added heat reclaim or something, or if they added something else
Right.
to the system as they evolve it. And this is where it's so important to ask those questions, because when I go to a field startup and I'm with the manufacturers and the EMS and the control guys, I'm like, this is the time telling the technician to ask the question. But they're like, well, I got to do all this work. I got to pull wire. I totally understand. But usually you're
Yeah.
there for a couple of days.
Right.
And in that couple of days is ask those questions and build a relationship with
Mhm.
those people. That's how you continue to grow and learn and offer. I think the biggest thing is saying, I don't know. And
Yeah.
what can I do next? How can we go forward with this?
Yeah, yeah, and there's a lot of situations where, fortunately, I've been working with the same crews sometimes more than once, and each time we're learning together,
Yeah.
and we're kind of feeding off of each other and sharing ideas, and like, hey, I think if we do this, this will happen. Let's try it, that sort of thing, so that every time you do a startup, you end up with a better product. I think that's the end because continuous improvement just never goes away.
Yeah, and I totally agree with that. I got a question for you. So you've been doing technical support for over 3 decades now. With all the electronics, all the pressure transducers, temperature probes, I believe that it's helping us teach people faster so they can understand the systems. Because when I was a technician in the field, I'd have to put a set of gauges here, one on the roof, one out of the case, and I'm running around to see all these different things, and they're changing at all times. So by the time I
Right.
get to the next one, it's different. Do you feel that these electronics are helping the industry grow their knowledge and people in the industry, or is it slowing the growth of them down? I guess that's a
I think
leading
I think
question.
in the long run it's helping because now if you want to, you can turn on history for all these pressure transducers you have all over the store. I think in the short term it gets frustrating for guys because there's so many transducers to
Yeah.
think about. And I sit them down, and before we start the rack, I say, "Hey, we're going to check all the transducers on the floor, and we're going to make a list of the ones that are not reading, and we're just not going to start those cases until we get good readings there." And I explain why,
Yeah.
because typically that will set you back with low superheat and all sorts of issues, and now you've got to chase that down. But I think if you use all those tools, then you come out ahead. But in the beginning, I think it is frustrating with guys because they just feel like they're just putting out fires when they'd rather be starting the rack.
Yeah. And I had this conversation with many people. It's like, my good friend Kevin, he was like, a lot of people just want to get the CO2 in the system. Let's get it in the system. But it's easy to put CO2 in the system. The thing is
Right.
doing all the prep work, which is the hard stuff, right?
Yeah. Yeah.
And now we see it all. Where before it's like if a TX is not working, you don't see that until you're running for a while, and then all of a sudden, oh, it's not pulling down temperature. Where now you check that, the temperature
Yeah.
probe and the pressure probe before you even start it up. So, what are your thoughts on that? Have you noticed that people are trying to get the racks up too fast versus before? Because the timelines I'm seeing for the amount of electronics, people are rushing schedules. Have you noticed that?
I've been really fortunate because on the West Coast, we've been running ahead of schedule.
Awesome. I
So
love hearing that.
yeah, we are months ahead to the point where there's no dry goods in the store. They're not even talking about bringing product in for weeks or maybe months. And now we've got power, we've got water, so we have the opportunity to get the rack going. And yeah, it's
Good.
not an issue here. So I'm going to pause and put my teams on do not disturb just so we can keep that from popping in here.
Yeah.
But yeah, it's you've been really fortunate because I told those guys, you guys are way ahead because on the East Coast it's usually push, 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 and yeah, a lot of times I say, hey, we're not going to sweat it. We're starting on Monday. If the rack's not running till Wednesday, it's okay. But yeah, there are guys that walk in and say, hey, why isn't this rack running on Tuesday? Well, we're not done checking everything yet.
Yeah.
And the more I talk about it, the more people buy into it and they say, hey, I'm fine with that. Let's just check it because if we start this thing, we don't really want to shut it down and start scratching our heads on this. And they're fine with that.
Yeah.
So we do check a lot of stuff, and I'm developing a pretty lengthy checklist for the control side
Yeah.
for Safeway and Albertsons,
Good.
saying, okay, we got to run through all this stuff, and then you can start charging, because it doesn't take that long to charge, and usually they do 2 racks, 5 compressors each, and
Yeah.
it's not that bad. We start one rack one day, and then typically the next rack the next day.
Yeah. I think that that's the big thing. Like when I talk to a lot of technicians in my supermarket program, like the things on that startup, because if you never did one before, the first one is going to be the hardest. The second one is going to be less as hard because you're going to learn a little bit, and it's so on and so forth. But
Yep.
there's such a huge demand at this point to find startup technicians.
Hmm.
And I keep telling the technicians in my community, well, you got to ask for it. One thing, when you get in there, you got to try really hard because there's a
Yeah.
lot to know, right? As you
Yeah.
know,
Yeah.
if you have a
Yeah.
200 case store, that's
Hmm.
thousands of temperature probes and transducers. You know,
Right. Right. Yeah. Yeah. And you just hope that the OEMs have done their due diligence, and there's always something's going to fall through the cracks. Because when you look inside that rack and you think about how many wire connections there are, there's a lot of things to go wrong, as you know. So yeah, out at the case side, things have been pretty good.
yeah.
Obviously, there's some things that have to get caught and fixed up front, but on the rack side, it's been a little bit of this and a little bit of that. They're never perfect, but you don't really expect them to be. But yeah, you learn a little bit more like, okay, the last job we didn't have to check that, but this job we do.
Yeah.
And if it's wrong on one rack, it's probably wrong in the other rack. And you kind of learn from that.
What are some of the top things that you want to teach when you're going to a new store? So you've been working with a lot of contractors that have, which is great, the same contractor over again, so you can teach them each time. But if you're coming up to, say, a new contractor you haven't really worked with before, they understand Danfoss a little bit because I'm working with a lot of technicians coming to my program and say, I've not worked with Danfoss before, or I work with Danfoss before. What's some of the advice that you give them? So if you're going to meet up and you're ready to do a startup, and it's with a new contractor and the manufacturer you would know because you know all the
Mhm.
manufacturers, right? What are some of the things that you set the kind of the ground rules for everyone to
Mhm.
work on the same team?
Yeah, it's amazing how when you arrive, they put you in charge right away,
Yeah.
which surprised me in some cases. I've been other in situations where you're kind of thrown in when the startup is not going well, and you're brought in at the in the middle somewhere. But yeah, the funny thing is they'll put you in charge. But in a normal startup, if we would walk in and say, okay, this is new contractor, yeah, we have a kind of a little powwow on day one and say, okay, these are the things that we want to go through. We need to make sure that we have solid communication loops to the cases so that we can see what's going on in the cases and then say, okay, how many pounds should we have in the cases at this point? So we can do a sweep through the cases and check all those to see if our pressure transducers are reading. That's one of the biggest things that we run into is just that there's a lot of things that have to be fixed out there.
Yeah.
Once you get those pressure transducers reading, then you're in much better shape. And I tell them, hey, if we can get 80% of the cases and they're ready to go, that's fine. That's all we need. And then we'll work on that other 20%. But if, as you know, the case controller has a main switch in it, like most of our controllers do, and we just leave it off if the case isn't ready. And then when it's ready to bring online, we turn on the main switch and let it do its thing. But yeah, I tell them that, hey, we'll just knock out as many transducers issues as we can, and we'll start those cases, and then I'll prepare that custom screen I talked about back on the rack side, so that when it comes time to say, okay, we've got enough charge, let's start this baby, then that's the screen everybody will be looking at. You know, what's my superheat? What are my suction pressures? And how am I doing on the high side? And how much is the receiver open? Stuff like that.
Yeah.
And when it doesn't work at first or only partially works, then we're sharing ideas and saying, okay, that makes sense. That's why, this valve is keeping us from building pressure in the receiver and stuff like that.
Yeah.
So it's been a good learning experience all around.
What is the biggest learning curve you think for technician, even if they're experienced in supermarket and even experience with Danfoss controllers? What is some of the biggest learning curve for them on these new transcritical systems that you see?
I think it's kind of explaining the sort of the decentralized control that we have, because you're probably aware that we have a pack controller, and that pack controller is could sit there and run on its own. Doesn't need the system manager, but the system manager ties everything together. and it gives them a way to look at things a little more easily. And then you've got the case controllers are doing their own thing. So often they will ask, what happens if this goes down? And the answer is, well, it's going to keep going. So yeah, it's explaining that you don't need the system manager necessarily to keep things running. And that's kind of a different concept for them. They're used to an Emerson where everything's coming out of the E2 or E3. And yeah, those are probably some of the main things. And then just explaining how we do restarts, gradual restarts on the CO2 to manage the load.
Why don't we dive into that a little? Yeah, let's dive into that a little bit. The gradual. What do you mean by that? Because some people on an HFC rack, you can go and just shut all the breakers on the compressors, and that's it. It just stops the refrigeration. You definitely can't do that with CO2 transcritical systems. Okay, so
right.
So what is some of this that you talk about?
Yeah, so on the CO2 systems, if you just let it rip and let all the cases come back online at will, ignore maximum operating pressure, MOP, then you're going to overload the rack. So it's pretty standard now to divide the cases into groups. And when you see things like a phase loss or that nothing is running back at the rack, that everybody has to get the command to shut down. And then we have a discussion with the contractor and say, okay, which cases do you want to bring back online first? Are you more concerned about fresh meat or ice cream or the walk-ins, or what is it? And then we divide them up into groups based on priority. So we'll bring in group one first. Once we see that there's nothing holding us back at the rack. And then at the same time, the case controllers are looking at MOP, and we agree on some settings for that, so that suction pressure has to be within a certain range at the rack before we can say, okay, it's time to start feeding out at the case level. And then we talk about the timing, because the timing can change from store to store. Mm-hmm. And what worked in one store may be too long in another store. So we look at the grouping of those cases and say, okay, after 4 minutes, we can bring on the next group, and then make sure the rack can handle that. And the OEMs are pretty good about saying, hey, before I leave here, we're going to test this. So, and everybody is there to see it happen, so that they know that, okay, if I have a problem with the phase monitor and it shuts me down, it's going to take me 20 minutes to get back up and running again.
Yeah, and I think that's so important. And MOP means maximum operating pressure in your suction, so it'll stop your EEV to open up wide open to protect the system for overload, just like Dave said. I think this is where some technicians are like worried about it. Like, how do I, if it shuts down, will it start back up? This is all something that is pre-programmed in there. Before you release this to the customer, it should be tested. And sometimes it is, and some of it isn't. But I know I talked to a lot of technicians in my program, and they're saying, like, Trevor, I'm worried about if the store goes down, I won't know how to start it back up.
Yeah. It's a valid concern. And that's one of the reasons why we get everything on one screen. So if the technician locks up, that we can talk to them and say, okay, what's your receiver pressure, and what's your what we call PO, the suction pressure for both the medium and the low temp, and what's your PC, your condensing pressure, so that we can get a picture of the whole system and see, okay, is there something electrical that's holding us out, or are we just in a delay before the pack controller says, okay, everything's good, we're going to starting with the variable speed drive.
Just a second here, Dave. Do you know who Deborah Shapiro is?
Yeah. Yep.
Should let her in?
She's in marketing on our side. Yeah.
Okay, I'll just let her in. Yep. Adam, just edit out this little section here.
Yep. Yep. And Lisa Trison wanted an invite. You may know her.
I seen her name popped up, but she just popped out of the chat. So Deborah, hey Deborah, I just stopped.
Hi. Yeah, Lisa was having some connection issues. So yeah, I'm here. Michael sent me the link, so I'm here.
Just monitoring Dave. We need to monitor him. Thanks.
Hi, Dave.
Hey, how are you?
Good. How are you?
Lisa did
Good.
pop on, but we were chatting, so I didn't let her in yet. So if she does want to come back in and listen, I'll just add her in. Okay.
Okay. Yeah. Let me tell her. I think well, no, what she says is I can't get through even though it looks like I'm connected.
No, she was there. No, I just didn't let her in. I was talking to Dave, but I let you in and we stopped it. Now we're going to start all over again, Dave.
No problem.
Okay. So that there is definitely a huge concern, and which I talk to technicians about. That's not what you need to worry about if you're servicing the store. That should already be done through the startup with the OEMs as well as your startup team. But I keep telling them when you leave this program, you get your first CO₂ store, you and your team should go out and actually do a power outage or do a shutdown so you know what it looks like and feels like. Because like you said, you guys want that to happen before you leave. So they know what to expect. Because if it doesn't come back online, then there's some things that they can ask you at that point.
Right. Yeah. And we talk about worst case scenarios and things like that. Some of the OEMs out there actually put suction stop valves. Almost like a holdback valve on the suction side that is driven. It's a 4-wire stepper valve driven by a driver, which gets its signal from the system manager that says, okay, at this point, I want you to open this much. It's sort of a safety on how to manage the load coming back. And if that valve doesn't open all the way for some reason, we talk about what possibilities they have to maybe override it temporarily or put a valve driver on it, those sort of things. So, I often ask the startup guys, how do you hand this over to the maintenance guys? And sometimes there's a shrug, and they're like, well, we have a talk about it, and then they're on their own. Yeah. But as you know, the startup guys are on to the next one usually at that point. And but yeah. They will kind of hand my phone number down the line if they have to, which is good and bad at the same time. But my feeling is if you do the startup well, that there's less problems down the road.
Totally agree with that. Like I've seen, I've been talking and training people from all over the world, and they're coming in and hearing all these different stories. And it always comes down to usually the startup. If the startup was done right and it was thorough, and they, you know what I mean? Even the finest details, stuff does come up, but it's all about that initial startup. And if that is rock solid, you have way less issues. When it starts to get cold out, like here, we're 26 Fahrenheit right now, minus a couple Celsius. And it get down to minus 17 Celsius. So minus 20 there a few days or last week, right? So really cold. Yeah. And in my community group, we had a bunch of guys that were doing CO₂. One guy was out of, was it Michigan? I can't remember what place he said, but he's like, it got super cold. My head pressure dropped all the way down to 570, or you know what I mean? I'm like, what? They got down that low? And like your flash tank, what's that supposed to be? Well, we're supposed to be running it at 520, I think it was PSI, but it was running at like 450. And then I'm like, what is your suction? Well, we're trying to do plus 20, which is 407. You know what I mean? I'm like, it's way too low. So why is it going that low? You know what I mean? Yeah. What caused it? What was your minimum gas cooler set point on your ISTM valve? Or, so it's like understanding that. And because if that was all programmed in first, if that was programmed in, that should stop at that specific minimum gas cooler temperature outside. And then, but it was maybe missed, and he's diving into it now because this was just last week. But everything was fine in the summertime. Like everything ran good in the summertime, but now the first cold snap run into a bit of an issue. And this does happen, but that there is the difference between like a really solid startup to something that was okay. Yeah.
I feel for the guys that are starting up some of the smaller stores that are coming online where the CO₂ rack is plopped on the roof and it's 15 degrees outside Fahrenheit, and they're trying to start the rack. So you're fighting the elements when you're trying to get this rack up and running. Fortunately, there's a lot of similarity from job to job, but still, that's brutal.
Yeah.
But one of the things I run into is that you can't start the whole system when everyone's there typically. So we have a chat about that because heat reclaim typically comes online much later. And we make sure that we have remote communication to the site, and that, okay, here's my plan for helping you start heat reclaim. That when you get to that point, and they've got it all ready to go, then let's walk through it so that I understand how they want it to work. You understand. We kind of start it gradually to make sure the rack is going to be able to handle it, and then kind of see how it goes. But you understand how much heat is potentially there. So, you can really take advantage of it. But it's never ready on day one. That's just the way it goes.
Yeah. And I definitely agree with that. I think there's a lot to do. Once we talked about earlier is the sequence of operation. I feel, as I do my trainings and training more people, is that a lot of technicians don't understand the sequence of our operation. And I'll be honest, when I was in the field for 10 years, I didn't understand that. I understand some of it, or right. I understand like a piece of the sequence of operation, but not the full end-to-end operation. And there's just way more sequence of operation in a CO₂ system, I feel, versus an HFC or a standard rack.
Yeah. And it continually changes, and I'm still learning it. And now we have things like the ability to bypass gas coolers.
Yeah.
We can add that valve in there if people want it, if they spec it in. So guys have to understand, what are the conditions where you might bypass that gas cooler and things like that. So, but another thing that's mentioned a lot is when things are not going well and they're kind of going sideways on you, the guys will kind of look at each other and say, okay, let's start at the basics.
Yeah.
And a lot of times that's where the problem lies, is that, we really thought that valve was working the way it's supposed to, but it's actually wired wrong. And that explains all these other things. So, but a lot of that happens not only in CO₂, but everything, it seems like.
Yeah. No, I've had a guy in the training say, Trevor, I went up, we're doing a startup, and all of a sudden the high pressure valve, the Danfoss valve, was not working. It was all over the place. Flash tank was crazy volatile. And I'm like, okay, what did you do? Like, did you go check the drop leg sensor? And they were like, yeah, we went up there and it was a CPC sensor. And I'm like, what do you mean it was a CPC? Yeah, it was the green wire from Emerson and I'm like, but what controller was that? And that was I think it was a 782. No, it was an EKC 326. That's what it was.
Okay. Yeah. Okay.
But you need a PT 1000 temperature probe, not an NTC probe. And he was like, they didn't know that. And that was the major issue. You know what I mean? Yeah. So, and it can happen. Yeah. I don't blame the technician, because you just don't know, because I always grab that sensor and I use that for everything.
Right. Right. Yeah. We've seen, how critical the gas, the sensor coming out of the gas cooler. Get a lot of questions on that. Like, does it really have to be within? We say within a meter, but the real answer is as close as possible. And hey, that's a really important sensor. What if that sensor goes bad? Well, the pack controller allows you to put two sensors in there. And if one goes bad, it'll know how to switch to the other one and alarm out if that temperature difference is too large. But the last job, it was coming out of the gas cooler, probably in the right place, but it was insulated with black tape. And they're like, hey, it's only 40 degrees outside. Why is it reading 75? I said, well, you can start the rack and it'll run, but it's not right. So we talked about how to insulate that correctly and reflect some of that sunlight off of there. So, those are, like you said, the basic things that you have to cover.
I do have a question for you too, because I'm hearing different opinions on it, and you may not be able to answer it. But if I have a two circuit gas cooler, so I got two liquids coming out, and then they tee in together, where would you recommend that technician to put the drop leg sensor? On the fixed or the full year-round outlet, or would you put it on where it's teed at the outlet there? What is your opinion? Because everyone has their own. I put it here right by the gas cooler within 6 to 12 inches, 150 mil to 30 centimeters, or I put it right at the outlet where the two of them come together.
Yeah. Chris Brown could probably give you an even better answer, but the widely accepted answer is at that common point. If you're only going to put one sensor in, just use the common point.
Yeah.
If you're going to use two sensors, then I would say you would probably want to put one on the year-round side and one on the common point.
Yeah.
Because really there should be very little difference there.
Yeah. So anyone who's listening on the podcast or the YouTube channel, if you put two on there, one on the outlet of the one that's running year round and one on the common, I would love you to email me in info@refrigerationmentor.com or Trevor@refrigerationmentor.com and let me know the differences year round. I'd love to see that trend graph. And I'm sure you may even have it, Dave, but I want to see that because I have people in Australia say, no, it has to be at the common. And the other people say, no, it has to be 6 inches from the gas cooler. So if anyone's listening that has that data, please send it in because I'd love to know. I'd love to see because everyone has their own preference. It works better here. No, it works better here.
Right. Yeah. Yep.
What we do know, it needs to be really insulated. It can't be, you know what I mean? It has to be strapped properly at the right location, 4 and 6 or 8 and 10, depending on the size of the pipe, but we don't want it at the bottom.
Right. Yeah. And guys are getting better at insulating them and then putting kind of a white plastic cover over those to keep that sun influence out of the picture. But yeah, I think this will be debated for a while until we come up with the correct wording for the science on why it needs to be as close as possible and then prove it. That you get a better operation because some people are even wanting to put them down in the compressor room and will swear that it works better. So,
I know, but that's the big thing is well, it's only 12 feet away. You know what I mean? It's only 4 meters. Like there can't be that much big of a difference,
Right. Yeah.
There is. This is why it's because you guys aren't new to CO2. This is the thing is like you guys been doing CO2 for 25 years, 20 years. Like it's not new. But the way we are evolving is new and these new ways of doing CO2 is evolving, which is cool. And what you must love, it's really coming back to the controller side. Like I keep talking to the technicians in my programs, like we got to get you in more controller. So we're doing more controller training and we're teaching. Like even last night in my supermarket course, we were going through how to set up a Danfoss drive to a compressor. You know what I mean? Because that's still something new, even though we've been doing it for 2-3 decades on compressors, even longer. But we're going through it now. We went through the program. Was okay. What are those parameters that you need? How do you wire it up properly? Because a lot of them, as you know, are in bypass out there. Not on CO2 systems, but on most of the systems that have a drive on it. It's just in bypass. Oh, there's something wrong with it. They put it in bypass, and then nobody goes back. And there are like even the guy that last night was like, I was afraid of it until we talked about it, Trevor. Now I want to learn more about it. I'm going to try to embrace it. It's hard because I never did it before, but I want to learn. And then when you want to learn, you want to grow. I'd love to hear about some of those stories on the drive set up because I'm sure you've heard tons of these stories. What is the big hesitance of a technician having a drive on a compressor on a rack? What do you feel it is?
Well, and you're right. when I started in the early 90s, there were a lot of drives on racks. But the long-term commitment wasn't always there. Because of course the technology was not as reliable, and if the drive went down, they put it in bypass, and then people gave up on it, and they didn't want to spend the money to get it replaced or up and running or fixed. So people went away from them for quite a while. Now with the emergence of CO2, people see the value in those, and fortunately, the Danfoss drive is so widely known and accepted that the OEMs are really pretty familiar with those, and they take ownership of it. They set it up, they program it, they know how to copy to the keypad, all those good things. From what I've seen, for the most part, if there's a drive issue, it has something to do with a loose connection in at the lugs somewhere, maybe a control wiring problem that has to get sorted out, but by and large, they don't seem to give us problems. And if there is a problem, then they call our drives division out in Chicago and get some support to figure out what's going on with it. But the drive doesn't seem to be a huge issue at this point, from what I've seen. It's just a matter of understanding the value.
Yeah, no, I think so. And it's the unknown, right? If you haven't worked on it before, you're a little hesitant, but you got to get in the manual. You got to understand what the wiring is. you make sure you do not touch any of those wires, drives, you shut them down and wait 10 minutes. It says right there in the first, you know what I mean? 5-10 minutes capacitor.
Yeah.
So be safe on that
Right.
stuff. But we're going to see more and more of that on CO2 systems. And I think everyone that I've been to, there's a drive on it. You know what I mean? On the rack.
Yeah.
So that's very, very important. So
some of these, if I can, some of the maintenance managers, construction managers, the guys that are saying, let's put a drive out there, they're getting wise to some of the tricks. So they're alarming out if the drive goes into bypass and if the drive goes offline.
Yeah.
Because depending on, how you tie it in, the drive can talk to the system manager. And that allows you to alarm if it goes offline. So if it goes offline for an hour or two, that's okay, because it's probably maintenance. But if it's been offline for a week, now there's some questions are going to be raised.
Yeah, because that really defeats the purpose of having it. You can run the system with a drive in a bypass, because there's thousands of them probably out there right now. But the thing is that with the drive or with some capacity control, that just makes the system run and purr so much better. And it's so important in CO2 that the rack is stable, so your high pressure valve stable, so your flash gas bypass is stable, and all your EEVs are stable. And when you have all those four things working in conjunction, you're going to have a good running transcritical CO2 system.
Yeah, and I think the really valuable guys out there are the ones that can come back to the store after the product's loaded and tune it. Because
you brought that up.
I don't see a lot of that, but there are a few guys out there that know how to do it. I'm not one of them yet, but I want to get there, obviously. But yeah, there's so much fine tuning that can take place, and once you have that, you should only really need to do it once.
Yeah. And the rest is just maintenance on top of that, just the standard maintenance like you're supposed to do in your standard stores at this point,
Yeah.
The big thing I've seen that as well. Like I work with a lot of the technicians that I work with, is that learning the fine tuning, that case controller after, because you do the startup, but you got to come back in like a few weeks later or be someone monitoring and then do the final adjustments, because that case controller, that case in the bakery with these set points, well, maybe all of a sudden they move that where that oven is. You know what I mean?
Yeah.
Or it's a lot hotter than was expected or anticipated. Or where these deli open cases now have diffusers that are shooting down, and you're getting a little more infiltration or broken air than you can, but you can't do anything about it. It's not like all of a sudden you're going up and putting cutting out the diffuser. So you got to work with that stuff.
Yeah. True. Yep.
And I think a lot of fine tuning is fine tuning difficult. I don't think it is. I think it just takes time to learn the store at hand, right?
Yeah.
And not every case control, you can't put the same parameters in, so it takes time to learn each one.
Right. Yep. I think you, like anything else, you develop a punch list based on the biggest issue you see and kind of work from there. And look at how, obviously graphing and trending is super important there. You get your baseline, and then you say, okay, I'm going to adjust this P setting or this I setting a little bit and see how my valve reacts. And then, but yeah, one thing affects the other in a big way.
Yeah, I like that you bring that up, because that's a big question in my trainings. Is like, Trevor, I really need to understand the P and the I. Do you want to explain both of those? Because a lot of people say, oh, well, I need to know P and ID. I need to know P and ID and how to adjust it and how to train it. But you guys have been developing this stuff for decades. Like these controllers, you've been working on the P and IDs, all the big control manufacturers. So people don't have to go in and really adjust them. That baseline is usually good. You know what I mean? But there is some fine tuning. You want to talk about what that really means and when someone should look at adjusting the P or the I or the D, depending on the controller, and what those really mean?
Yeah. So a lot of times we will run into people that are used to Emerson because they do a lot of PID stuff.
Yeah.
Danfoss breaks it down, and a lot of times they'll drop out the D part, and they'll just do the P or the P and the I. Typically, the P and the I is what you see the most. Yeah. But for us, if you see a setting called KP, capital K, lowercase p, that's the P setting in our controller. And then TN is the I setting. So capital T, lowercase n is the I setting. And the KP setting will adjust the P parameter um, a little bit at a time. And the golden rule always seems to be that you make a small adjustment and then you wait, and you don't change both of them at the same time and then kind of stand back and see what happens. But you typically will adjust the KP setting first, just a little bit, and then if you're not quite happy with the results, you can change the TN setting. And in general, it seems to be that you're trying to slow things down, which is counterintuitive, because you look at it and see it kind of hunting around and say, if only I could get it to react quicker, I'd be fine. But talking to guys like Mark Sever, who over in Europe, it's a Danfoss guy, really smart with CO2 and controls, and he said in general you want to slow it down, and that's generally where you start. But you got to have a baseline and remember those numbers you started with, because you might have to walk them back. And the biggest thing I think is that we don't give ourselves time to work on this stuff.
Yeah, I like that. I like what you said first there. Sorry, Dave, that you don't change it and then second later you change the other one and you change two of them at the same time. It's like process of elimination. You move it up or down. So for an example, if we change the KP, so that's the proportional. If I increase it, does it go from 0? I can't remember honestly, 0 to 100, or what's the range?
Most of these are going to be 1 to 10.
1 to 10. So if I move it from say 5 to 6, is that speeding it up or slowing it down? Do you want to kind of explain how does that work? If I move it from 5 up to 6, what does that do? And if I move from 5 to 4, what does that do?
Yeah, most of these will tell you, and let's say that we're in the pack controller and we want to adjust something, then the pack controller and the service tool software will tell you what your range is. But if you go from a 5 to, or like a 2.0 to a 2.5, you're telling it to respond a little quicker based on how far you are from your target. So as you go up in number, you're going to tell it to react a little quicker. And then on the TN side, you're working with a window of time and how you want it to look at those samples. So a wider window might help you. A wider window of time, meaning you're going up in the number of seconds, that may help you, rather than take a shorter time window for this controller to figure out what it needs to do. But it is really cool when you find one that's not behaving itself and you find the right combination. The PI setting is kind of magical.
Yeah. And once again, this is something that takes time. Work with someone who knows how to use these. And it's not something you just keep changing. Sometimes you got to let it go for a few days, and just watch it. It's not like you change it and then 10 minutes later, it's going to be working perfectly. Maybe it's got to iron out some issues. And you can get a bigger timeline than just you change it from 2 to 2.5. This is just examples, but you may have to see and look at a bigger timeline than just an hour.
Right. And then, and before you even start, you start combing through the history, because the pack controller has tons and tons of parameters in there. And there's ones that you definitely want to capture in history, because that's going to tell the tale when you come back the next day and say, okay, how am I doing on these changes I just made? So it's an easy thing to forget, is to go into history and think about all these parameters that I want to have start logging, and it'll help you sort it out after the fact.
Yeah. I think that's a great point, is understanding the history, understanding the trends. And before you even adjust these P and I, I don't recommend it. You got to make sure all the basics, like you said way earlier, if it's a case controller, airflow, all the fans running, is the honeycombs clean or dirty, is there something blowing in? All the basics need to be checked first. Is my valve even opening up properly? Like, did someone put a maximum opening percentage of 50 in there and it's not fully opening or closed? Like, there's all these other, you don't go change that until you know all the other parameters are where you want them. So there's a lot to it.
Yeah, there is. Once guys do a couple of jobs, then they kind of start to get the hang of it and realize that, okay, it seems like there's a lot here, but it's manageable. It's just that the numbers scare them sometimes, because like you said, you've got so much to do and they want to get the rack running and all this, but yeah, you have to back it up a little bit and then just go through there. And sometimes we'll get a group of 3 people if we have to go through all the case settings and say, we think these are like 90%, but let's kind of make sure. And if we see we need to adjust something, we agree on a new setting and we go with it.
I love that.
And then we try to get better on the next one so that those settings are already there waiting for us.
Man, I love this conversation. We could keep going all day.
Yeah.
All day.
Yep.
What would be 1 or 2 tips of someone starting to work on CO₂? They did supermarket for a while, but they work on Danfoss controllers, but they're going to start doing some either startup or service work or maintenance work on a transcritical store. What are a couple of tips that you can offer them?
Well, there are guys that are not, the laptop is not part of their everyday tool bag.
I like that one. I like it.
Yeah. So, and that's okay. Because the laptop it should be something that they have now.
Yeah.
And laptops have come a long way in the last 30 years. So they don't have to be expensive, but once you get the laptop, get the cable, get the software that lets you plug right into the pack controller, and you can log in and you can look around and familiarize yourself with the menus, and you aren't going to break anything. You're just creating some familiarity. And then what I show the guys is here's how you use the Wi-Fi to connect to the system manager. Here's how you back up the file on the pack controller, because it can get forgotten. But use the laptop to back up the file on the pack controller, because bad things can happen.
Oh, yeah.
Not often. Not often. But when the water's dripping out of the pack controller, you're going to have to change it. So you're going to want that file to put it back in there, because all those PI settings need to be put back just the way it was. And the backup file is your best friend at that point. So we're not asking them to be laptop experts or anything like that. We just want them to be able to back up files, familiarize themselves with the menus before they are sweating because the rack's not running. And it just helps them down the road.
Oh, I totally agree with that. I've been using a laptop in refrigeration for over a decade now.
Yeah.
And a lot of technicians say, I'm scared of it as another tool. Why do I need it? They're expensive. I'll break it in my truck. I'm hands-on for Trevor, so I throw things around, Yeah. But the more technicians in my program, I get them to download the service tool, or they get to download different things like Cool Selector is another one. Why would I use Cool Selector? But when they start getting into it, that's where all the manuals are. You know what I mean? You might not use it every day. Well, I can do it on my phone. Well, for me, I do a lot of work on my phone. I do my whole business on my phone sometimes, but I need a computer to look at some small print sometimes. Look at wiring diagrams. It's a lot bigger. You can see a bigger view. And I did a CO₂ experts with Damon Reed from Pro Refrigeration. They use a lot of Danfoss, and we were going through how you use the service tool, how he uses the service tool, and the value as a technician, where you can see the whole thing and make it's to make it easier. We're not trying to make it more complicated. You guys are trying to make it easier for the technician. Can it be frustrating learning something new? 100%. I'm used to gauges that are analog, and I'm used to these old temperature pro. Well, digital stuff came a long way to help us out.
Yeah. They're more used to that wrench in their hand than a laptop. And, sometimes we had to go right there with them and teach them the basics. Like, hey, this is where you plug things in. And even though the cable fits in here, it's still the wrong port. And here's how you figure out the COM port and, that kind of stuff. So, they're just glad their kids aren't there to see them struggle with their laptop sometimes.
That's totally
but it helps them in the long run. And these days guys have to email from the job site and all that sort of thing anyway, and something they didn't do 10 years ago.
And everyone that's come through my program that has started using a computer and a laptop, they're like, it's making my life easier. Where I was fighting it for a long time. I'm like, oh, I don't need that. But it's making it easier. Dave, before we go, why don't you tell us a little bit about controller talk? Because that's a great listen for me. I listened in. It's a lot of times at the gym, because I listen to a lot of podcasts at the gym. Tell me a little bit about controller talk, where you and Chris are going with it, because I've learned a lot about Danfoss from you and Chris on that. So let us know a little bit about it.
Yeah, so maybe 3 years ago, one of the marketing people came to Chris and myself and said, "Hey, would you guys like to start a podcast?" And like a couple of naive kids, we said, "Oh, I guess so," and knew nothing about it. Marketing does all the heavy lifting, like the recording and the cleaning up and all that stuff, and we just take ideas from calls that we've had or the emails that we get over and over. But it's been a really good experience, and we kind of decided that we were going to have our own little format and have fun with it. And I'm always trying to come up with these ridiculous questions for Chris.
I know.
And and most of these things I don't even know myself, but I'm willing to ask him and see if he can embarrass himself. But it's been a good experience, and we try to keep them down to like 20-30 minutes so that it's manageable, and maybe a guy can listen to one from job to job. And I talk to more of these guys that say, "Hey, I can't be on my phone while I'm in the van, but I can listen to a podcast." And so that gives them an opportunity to maybe take some dead time or downtime and do something with it. But we try to make sure that we're educating people. Like I said, we have fun with it and keep it relatively short. And then what's happening now is that listeners are feeding me ideas.
Yeah.
So they're telling me these are the things that I would like you to talk about. And it's been a good experience. So we usually try to release from essentially September to April every 2 weeks, and then take the summer off because you know what summers are like.
Yeah. Yeah. Crazy. The refrigeration industry. Awesome. So anyone listening, definitely go check out Controller Talk because it is a great podcast. I love learning from you guys. And if you're listening to this podcast, share it so other people can hear about both of the podcasts because Dave is a legend in the controls of Danfoss, training thousands of people and continues to share his knowledge and uplifts the industry because he cares. He wants to help. He wouldn't have been doing technical support for 30 years to help people because he didn't care. He does care, and he likes to see those successes when they happen. Dave, thank you so much for taking the time to talk with me at the Refrigeration Mentor Podcast, and I look forward to more conversations with you because this has been really awesome.
Yeah, it's been a pleasure. We're going to have you on our podcast, whether you like it or not, at some point here.
Yeah, I'm down. I'm down because I love learning. And one thing, honestly, like Danfoss controllers, I didn't in Canada. I have not seen any of them when I was in the field. You know what I mean? Like there wasn't much. And most was I started with an E2, and then microthermal started to take over. But then I started to see more and more Danfoss. And now I talk with lots of people about Danfoss because I deal with a lot of people in Europe, and Danfoss is a dominant player over there. And over time, is the more technicians come in, they ask me more Danfoss questions, which is great because I have to go learn. I feel like I'm getting better and better and better at Danfoss. Thank you for the invite. I appreciate that. But thank you for coming and sharing some knowledge with the listeners, and go out and check Controller Talk. Dave, thank you so much.
Yeah. Thank you for what you do to the industry, or for the industry, I should say. And I think it's been really good. It's been a pleasure being with you.
Awesome. Thank you so much, Dave.
All right. See ya. Thanks.
Awesome. I really